Hello, good afternoon, everyone. Today I will give you a small talk about the natural language processing and modeling of disaster threats. We used real-time trace classification to identify the disaster-related content, which serves as a foundational tool for building an early warning system based on threat social media signals. And the dataset provides about 10,000 labeled trees, and the task is to classify each tree into two categories. The first is the disaster, we label 1, and another is non-disaster, we label 0. And we use the natural language preprocessing to process the text, and this exploratory data analysis, and choose several modeling to fit it and evaluate this modeling. Finally, we will introduce some parameter to improve our model. We import two important natural language preprocessing package. The first one is RE, the other is NLTK, and we try to remove the unnecessary words. For example, there is some punctures, and we try to remove the punctures and to use the lematize and to make the words more similar and to join these words together. And this is the exploratory data analysis. Based on this data analysis, we can see the number of disasters and non-disaster samples is slightly imbalanced. And for the non-disasters, we have more samples than the disaster signals. And we also did a kernel density of tweet length, and we can see that for the length of we can see the distribution of tweet length. The disasters, the peak is more sharp than the non-disasters group. And this is the disasters group, and we can see the most common words are fire, news, via disaster, California suicide. And for the non-disasters group, we can see the words is very common. For example, like I am get new, you don't. Yes, so we can see there are still many words common to use. And this is the word cloud, and we can see that for the disaster group, we can see the thank you and Obama and everyone and warned, provoke, and improve extend for the non-disaster group as thank you everyone here, Lord, vibrate. And between these two groups, there are many words are similar. Therefore, we try to use the TF-IDF test vectorizer, and we try to reduce the common words and make the modeling is easier to distinguish which tokens, which articles, which signals is belong to the disaster group, and the other is belong to the non-disaster group. This is the modeling and evaluation. We use the logistic regression model as our baseline, and we try to apply the random forest model, XGBoost classified field model, and SVC model. And only the logistic regression model is a linear modeling, and three of them are not linear modeling. And we focus on record, and this is compromised by for another parameter precision. And we can see the formula of the recall is true positive divided true positive add false negative. And for the true positive, it means correctly predict disasters. For false negatives, is actually disasters that the model missed. For the warning systems, missing a real disaster can be very costly, as it may be lead to delayed response and increased harm. And therefore, we try to reduce the false negative numbers. This is the evaluation parameter from the logistic regression model. And we can see that the trend test, trend data, the accuracy is very good, 90%, and for the test data is about 81%. And the record of the non-disaster is 0.97. This is very good parameter. And for the disaster group is 0.8. Is also good. But for the task data, the non-disaster group is good, but for the disaster group is not well. So we try to improve our modeling. And then we comparison of the accuracy and record on the task data. For the logistic regression model, the accuracy is about 80.7%. Random forest is about 79.4%, and SG boost also 79.3. SVC is 80%. So for the accuracy, the logistic regression model is similar with the SVC modeling. But for the record disaster one, we can see that the parameter is about 0.68. These two groups are the best based on our modeling. We try to use the hyperparameter to tune to optimize the logistic regression model. And the data is the best is the C1, and the max DF is 0.5, and the ungrant is 1. And we can see that for the record is for the record of disaster group is a little bit improved, and the accuracy is a little bit improved than the baseline. And we try to use some strategy to raise the record of the disaster group, because the um, logistic regression modeling, we cut the 50%. This is the sigmoid curve. So we cut the 50% as the belong to 1, and below the 50% belong to 0. So we try to tune the threshold from the 50% to lower down to 40%. And we can see that the disaster group raise up the record, and normal group is also reduced the record. And this is we can expect this result. And the overall accuracy reduced from 80% to 77%. And the second, we try to tune the class weight. In the beginning, we said that our data is a little bit imbalanced. So we try to use the class weight, and to for the group with the smaller sample size, we raise up the ratio of the weight. So we make these two groups more have similar samples. So we can see that the record of the disaster group is from 0.69 raised up to 47 is better, but the overall accuracy reduced from 79 to 78. Yeah, so the trade-off is the higher sensitivity, slightly lower down the overall performance. This is the third strategy. We try to add alert terms, test length, and the negative words to create new features of the text. The alert words is about is like emergency, urgent, fired, earthquake. These words, and negative words like no, hate, bad, terrible, kill, death. These words, and we try to create a new features and apply to the logistic regression model again. And we can see that the accuracy is not lowered down too much, but the record of the digest group increased a lot from the original 0.69 to 0.76. So I think this strategy works. And this is the summary of this is a summary of the project. The key change and decision is that when I evaluate this modeling and I try to think which parameter is important for the warning system. And I realized that recall is important than the precision. So I try to increase the record based on the three strategies. And the takeaway homework is that I realized that how important it is that we choose or we create a good filters because some good filters help us to distinguish different groups. So I think we use the alone attempt and the negative attempts. It increase a lot to help the model to distinguish which kind of the text belong to the disasters. Thank you very much. I hope this presentation will give you some hint to know the natural language preprocessing and the modeling of the warning system. Thank you very much. Goodbye.